Hello, I'm Marcus, and I'm learning Rust by going through the Project Euler problems. Today is problem number 7. So problem 7 is find the 10,001st prime. So we have some of that, so let's dive in. So we worked on a primes module in a previous one. In problem 5, we worked on a primes one, and we just copied it over there. So let's make a proper library out of it so we can use this in all sorts of projects, and we don't have to copy the file as we go. So if we do a cargo init and you do --lib, it will create a library one. And so now we want to copy our source from before to, this is called primes. No, we did it in 5. Source primes, and copy that here. I think it's me to lib. So now in this project, we have our primes. We should better run our test pass. It's nothing new, so it's not a problem. And this cargo will say, well, we're creating it'll set the version, which we might need. We're not going to publish this. This is called a crate now, since it's a library. We're not going to publish it. We're just going to use it in local, so the version won't matter too much. All right, so now we need to import this in our problem 7, right? So for that, we go to our TOML, and we need to specify it in our dependencies. So we say primes equals, and then we need to tell it where it is. Usually you'd put in the version, and then it'd go fetch it from like GitHub or something like that. Or there's a crates.io. I'll fetch it from there. We need to say find it locally. So crates Rust crate local library. How to use a local unpublished crate. That's pretty much it. Okay, so we need to specify the path. And then specify the path. And then we should be able to do the, just do Rust cargo docs. Where's the cargo crates? Creating, yeah. That's just the outgoes. So we just specify the path here equals, and we're going to go up, and it's going to be there, right? Because this is relative to our project. So then in our project, we need to specify, now it's not a module, it's a crate. So I think we need to do extern crate. Let's just look at this one, see if it has it. Cargo lives, that's a project structure. I think it's like extern crate, extern create. How to use a local unpublished crate? Extern crate like that. Okay. So then I need to say, I need to tell, I was looking here. It looks like that. I need to tell the program that it's not a local module. It's going to be from external crate. And it's going to be called primes. It will look in the cargo file and say primes, and then look at that path there. So now we should be able to do a quick test and do primes, find primes up to 10. Oops. Run that, and there we go. All right, so now we have an external library, and we can do stuff. So this will find all the primes less than 10. You don't know the number, so we want to find, well, we can just create a function, right? Do primes find n primes. And then say 10, and want to find the first. We can do 6, because that was our example. 6, and then let primes equal, let p is equal that. And then d2 that. And so this should be find our first 6 primes, right? So now we need to write that function. So let's go to our library. Run source. That's called lib. All right, so we want to find pub function find n primes. And what I should do, it should be a relatively small number. I want to return a vector. These might be big. Let's not mix sizes. Doubt we'll ever ask for that many primes, but let primes equal our vector that we're going to return, and init that. Find and number of primes. I need to figure out, I don't know the proper documentation for that, so that might be worthwhile to do. We'll do that in the next one because we actually made a library. But there should be like a param num and then say what it is. I don't know how all that works for Rust. We'll do that for another, save that for another time. Return primes. And now we want to test function test find n primes and assert equals. If we find n primes and the number was 6, we would get back 1, 2, 3, 4, 5, 6 primes, right? All right, so to find the prime, I think we're gonna have to duplicate this because this loop is going up to a number. So it's not that hard of logic, but let's just duplicate it. Because it'd be harder to, I think, to it's be harder to make this neutral somehow, or like have one factor work for all of them, for one thing. Let's do that. We'll start with those primes. We just want to loop until what's our max int? Max is gonna be whatever. I don't know how to get the max int thing. Rest max int size. So I do U64 min. Let's just do that max. All right, U32 max. I doubt anyone is ever going to ask for that many primes. If we do, we can fix it. So then we can do max there, step by 2. We want to count how many primes we're finding. We start with 0. Actually, we start with 1, 2, 3, right? Because we have 3 primes there. And then as we loop, we are going to count a prime. Count equals count plus 1. And then if we get to if count is greater than num, break. I think we want exactly, so we want greater than or equal to. It should get to equal to, but that's fine. Now break that loop. All right, test prime U32 found U64. So we got some mismatches. U32. Oh, because I think I'm doing that. Maybe we do want this to be U64, and then it kind of treats everything the same. All right, that worked. Our test worked. So now we should be able to use this in our program over here. Source main makes this program really easy. Let's run this. And there's our primes, the last one. So it would be print line. QED would be PS length -1. Might be a better way to do the last item. So QED here would be 13 to get the 16th. 10,000. Let's see if we break things. If we say we want the 9,000th prime, let's not print that out because that's going to be obnoxious, and see what it does. It's going to take a second. There's a lot of primes. There you go. There's our 9,000th prime. So I'll leave it as an exercise to you to solve for the actual problem. But that is Euler number 7. Thanks a lot. Hopefully it was helpful. Cheers.